If you're tuning in, you're likely the kind of person who thrives on really understanding complex stuff, getting to the core of it. And that's precisely what we're doing today. We're going to cut through the noise and dive deep into a force that's shaping our world in ways we often don't even realize we're talking about: the incredible shrinking tech, the miniaturization of microelectronics.
It really is remarkable. Just think about it. Your smartphone, your smartwatch, the systems in your car, they're all getting smaller, more powerful, more energy efficient. It's a trend that's impacting just about every aspect of modern life.
Yeah, and it's easy to just take it for granted, but the engineering feats behind these advancements are astounding. We're diving into this topic today using some fascinating insights from a case study by Cognitive Market Research CMR. They took a close look at a leading semiconductor manufacturer, a company that was really struggling to keep up with this demand for ever tinier and more powerful electronics.
And as CMR lays out, this wasn't just a minor hiccup. The manufacturer was hitting a wall. Their traditional production methods, the ones that worked fine for larger components, were completely inadequate for this new era of ultra-small electronics.
So, we're going to break down the key challenges this manufacturer faced and the ingenious solutions they came up with to not just survive, but to really thrive in this age of miniaturization. Where should we start?
Well, the CMR study kicks off by painting a picture of this company confronting a pretty major obstacle. Their existing infrastructure just wasn't cut out for these incredibly small components. They were running into roadblocks at every stage, from the initial design phase to the intricate process of actually fabricating and integrating these tiny chips.
It was a problem on multiple levels, right? It wasn't just about shrinking the size, it was also about doing that while increasing processing speed, minimizing power consumption, and ensuring those chips remained absolutely reliable. Not an easy task.
No, not at all. The report dives into some specific technical hurdles, like the problem of heat management in these densely packed chips. These things get hot, and if you can't dissipate that heat effectively, performance plummets and the lifespan of the device takes a hit. Another big one was achieving the kind of precision needed to align components at the nanometer scale. We're talking about tolerances that are thousands of times thinner than a human hair.
I mean, these are engineering challenges that are pushing the absolute limits of what's physically possible.
Absolutely. And as the report emphasizes, it wasn't solely a technical puzzle. There were significant environmental considerations as well. Traditional semiconductor manufacturing can be pretty resource intensive. You're dealing with material waste, high energy consumption, and the use of some pretty nasty chemicals.
Yeah, it's a reminder that our hunger for the latest and greatest gadgets has real-world consequences. So for this manufacturer, it wasn't just about keeping up with the competition. It was about fundamentally adapting their processes to meet the demands of both this technological shift and an increasingly eco-conscious world.
And I think it's important to connect this back to what's happening in the broader tech landscape. CMR points out that we're in the midst of a pretty massive transformation driven by things like the Internet of Things, the explosion of AI, and the rollout of 5G networks.
All of which rely on, yeah, these smaller, more efficient microchips. So this wasn't just about staying afloat. It was about positioning themselves to ride this wave of innovation. If they didn't adapt, they were going to be left behind.
Exactly. So that's where CMR came in. They didn't offer some simple Band-Aid solution. They presented what they called a multifaceted approach, a strategic combination of cutting-edge technologies, process improvements, and a really strong emphasis on sustainability.
All right, let's unpack that. Let's start with those cutting-edge technologies.
Well, one of the highlights in the case study is the recommendation to adopt advanced photolithography. Now, I realize that might sound a bit intimidating, but think of it as a super precise way of using light to etch those intricate circuits onto silicon wafers.
So it's like drawing with light, but at a ridiculously small scale.
Precisely. The advanced part often refers to using shorter wavelengths of light ultraviolet or even extreme ultraviolet, because those shorter wavelengths allow for much finer details. This allows them to pack more transistors onto each chip. More transistors mean more processing power, and of course, it allows them to make those chips smaller overall.
So that's one piece of the puzzle. What else did CMR suggest?
Another really interesting recommendation was the incorporation of 3D printing, which may seem a bit counterintuitive because we usually associate 3D printing with making larger objects.
Right, like those little plastic trinkets, not exactly cutting-edge microelectronics.
True, but 3D printing at the micro scale is an entirely different game. The case study highlights how it can be used to fabricate complex microelectronic components with incredible precision and speed, even enabling designs that simply weren't possible with traditional methods.
It's about more than just size. Does 3D printing allow them to create entirely new kinds of structures, like structures that couldn't be made before?
You got it. Think about it this way. Imagine you're building a microchip, and instead of just layering components on top of each other, you can actually create intricate 3D structures within the chip itself. You could build cooling channels directly into the layers of transistors to better manage that heat issue we talked about. It opens up a whole new world of possibilities.
So, by bringing in these advanced manufacturing techniques, the manufacturer could finally start churning out these tiny high-performance chips without compromising on reliability or, I guess, their sanity.
Exactly. But acquiring the fanciest new equipment is only part of the equation. You need to make sure you're using it effectively, which is where process optimization comes into play.
So that's about fine-tuning their existing processes, squeezing every bit of efficiency out of their operations.
Exactly. The case study gets into specifics, talking about things like enhancing quality control measures, which is absolutely vital at these microscopic scales. Even a tiny defect can render an entire chip useless. By refining their processes, they were able to significantly increase their production yield, getting more usable chips from the same amount of raw materials.
Okay, so that means less waste and lower production costs. Those are wins any company can get behind.
Absolutely. And to ensure those tiny components function optimally, they needed to address the, well, as we mentioned before, the elephant in the room heat. Smaller, more powerful chips generate more heat in a smaller space, and that can really limit their performance and lifespan.
Right, and that's where some pretty amazing material science comes in, right? The case study talks about using graphene and carbon nanotubes. These materials sound like something out of science fiction.
Well, they kind of are. What makes graphene so special is its incredible ability to conduct heat away from those critical components. It's also incredibly strong and flexible at that scale, which opens up all sorts of possibilities for things like flexible electronics, which, we're just starting to explore. Carbon nanotubes have similar properties.
So it's not just about shrinking things down, it's about finding and implementing materials that can handle the demands of that miniaturization.
Exactly. And of course, we can't forget about energy efficiency.
Right, that's a big one these days.
CMR emphasized the importance of using energy-efficient materials in those chips. One they specifically mentioned is gallium nitride, or GaN.
Okay, I've heard of that, but to be honest, I don't really know what makes it special.
Well, the key is that GaN allows electrons to move through it more easily than traditional silicon. And what does that mean for you? Reduced power consumption and faster processing speeds. It's a win-win. Your devices use less energy and can handle more demanding tasks. This is especially critical for things like mobile devices and those internet-connected devices that make up the Internet of Things.
So these new materials are really driving innovation on multiple fronts.
Absolutely. Now, we've talked about advanced tech, process improvements, but we can't leave out the third pillar of CMR's solution, sustainability.
Right, because as we were saying earlier, you can't just ignore the environmental impact of electronics manufacturing. It's great to have all these cool gadgets, but not at the expense of the planet.
Exactly. And CMR's recommendations were pretty comprehensive. They pushed for using more sustainable materials throughout the manufacturing process, things like lead-free solder, and they advocated for reducing the use of those harmful chemicals we mentioned earlier.
Which makes sense from an environmental perspective, but it's also good business, right? Consumers are paying attention to these things now, and there's increasing pressure from regulators.
Absolutely. And it went beyond just materials. CMR also suggested investing in energy-efficient equipment for their manufacturing facilities, which helps reduce their carbon footprint. And one of the most interesting ideas was the concept of a closed-loop supply chain.
Now, that sounds a bit complicated. What exactly does that entail?
Imagine this. Instead of constantly mining and processing new raw materials to make chips, they could recover valuable metals, things like gold and copper, from old electronic devices and reuse them in new chips.
So it's about closing the loop, turning what would be waste into valuable resources.
Exactly. CMR stressed the importance of partnering with specialized recycling firms to make that happen. It's a big shift from the old take, make, dispose model to a more circular approach.
It sounds like CMR didn't just pull these recommendations out of thin air, they did their homework.
Oh yeah, the case study's really clear about that. They started by thoroughly assessing the manufacturer's entire operation. They did extensive interviews with key personnel, conducted market surveys to understand the demand and trends, and even dug deep into what their competitors were up to.
So a very holistic view of the situation.
Exactly. And then they took all that information, and they didn't just rely on gut feeling. They used advanced data analytics and computer simulations to model the impact of their proposed changes. They even did life cycle analyses of the materials and technologies to make sure they weren't creating new problems while trying to solve old ones. And of course, they kept a close eye on industry regulations, which, are constantly changing.
It's impressive. They really took a thorough, evidence-based approach. And the results, I'm guessing, speak for themselves.
Oh, absolutely. The case study is very clear about that. Implementing CMR's recommendations led to some really impressive improvements.
Okay, let's talk numbers. What kind of impact did this have?
Well, they saw a whopping 25% increase in overall production efficiency. That's huge. And they managed to reduce their total manufacturing costs by 15%.
Wow, those are some serious gains. So beyond those internal improvements, how did this impact their position in the market?
Well, because their chips were now more powerful, more reliable, and more energy efficient, they were able to grab a bigger piece of that rapidly growing microelectronics market. The report even mentions that this market is projected to hit something like $600 billion by 2025.
So they weren't just surviving, they were thriving.
Right, and it goes beyond market share. Their reputation within the industry got a major boost. Consumers and other companies saw them as a leader in innovation and sustainability. And, having a more efficient supply chain meant they could adapt to changes in demand much faster than their competitors. That's a huge advantage.
It's a great example of how embracing these new technologies and a commitment to sustainability can not only solve immediate problems, but can also create a real competitive edge.
Absolutely. So for our listeners out there, let's recap what we've learned. We've seen how a leading semiconductor manufacturer faced a real challenge in keeping up with the demand for smaller, more powerful microelectronics. We dug into the comprehensive solution offered by CMR, which involved a mix of advanced manufacturing techniques, process improvements, and a strong focus on sustainability. We talked about those incredible materials like graphene and gallium nitride, and we saw how all of this led to some pretty remarkable results: increased efficiency, reduced costs, a bigger market share, and a better reputation.
It really underscores just how much ingenuity and innovation goes into those tiny little chips that power so much of our world.
It does. And it raises some pretty interesting questions about the future. As our demand for even smaller and more powerful devices continues to grow, what role will material science play? Can we continue to push the boundaries of performance while also being mindful of the environmental impact?
It's a challenge, but clearly there are brilliant minds out there working on it. And it's something we'll all need to think about as we navigate this increasingly tech-driven world.
Absolutely.
Thanks for joining us today on this deep dive.
It's been a pleasure.